All right, so let's see one of the coolest things about alkynes. So before we get there, let's go ahead and check out something else. So we have our terminal alkyne that we learned how to synthesize last time, and we saw that if we added a strong base here, we can form our acetylide anion. And so we need a powerful base to do this. The sodium amide is powerful enough. Things like hydroxide and stuff are not going to be powerful enough to do this. So why is forming this acetylide anion important? And the reason that it's important is it will be used in this next reaction, right? So we have this alkyne, we add a base, we form our acetylide anion, and then to this we can add an alkyl halide. And so if we think back, we have a nucleophile here, we have an alkyl halide here, we can perform an SN2 reaction. And so what we've done here, let's go ahead and count the carbons and make sure we did this correctly, right? We have 1, 2, 3 carbons here, 1, 2, 3 carbons here, and then carbon number 4 and 5, carbon number 4 and 5. What we did here is we formed a new carbon-carbon bond. Right, and that's super important in terms of this course, because if you think about all the synthesis we've been doing, so far we've always had some kind of skeletal scaffold and we've been adding stuff onto it, but we've never been able to go from a small molecule to a big molecule. And so now we have a way to do this, right? So now we can make big molecules from small molecules by using an SN2 reaction between an alkyl halide and an acetylide anion. However, this only works for methyl and primary. So for example, if we have this acetylide anion and we have this methyl bromine, we'll get an SN2 reaction, so that's all good to go. If we have this ethyl bromide, again, that's a primary bromine, so we can go ahead and do our SN2. However, when we have secondary or tertiary, what's going to happen is instead of an SN2 reaction, we're going to get mostly E2 products. And so we'll reprotonate our acetylide anion and then end up with an alkene as the other product. And same thing goes for tertiary. Tertiary also leads to an E2 pathway. But nonetheless, it's still very powerful for these carbon-carbon single bonds. And then if we just use acetylene here, we can actually attach things to both sides of our compound. So in this first step, we can add some sodium amide to deprotonate. And then in the second step, we can add our alkyl halide to add on our first carbon-carbon group. And then we can just repeat this again with a different alkyl halide to add on to our second group. So we can form all kinds of carbon-carbon bonds. You have to do this in 2 separate steps. Because if you add this strong base and this alkyl halide together, you'll just get an E2 reaction, right? So you have to deprotonate, then attach one of your alkyl chains, deprotonate the other, and then attach another alkyl chain, right? And so this will let us do some cool tricks, such as maybe taking this propane and then making it into a pentane group, right? We can see we have 3 carbons here. We've got 3 carbons here. And then how are we going to attach these other 2 carbons? Well, one way is through this acetylide anion, right? So we could have our acetylene here, add our sodium amide to form our anion, and then have an alkyl halide to go ahead and finish this up. We see this is 1, 2, 3, 4. Just forgot to add 1 more carbon here. 5 carbons long. And then later on, we'll learn how to reduce this down to an alkane and do all kinds of other cool stuff with these compounds as well.